Hi students, welcome to Alpha's e-learning chemistry classes for second year. The running chapter is electrochemistry and now we are in session number 21. In previous session we learned about the electrode and single electrode potential, and potential is nothing but we observe that it is the tendency. An electrode may go for oxidation or reduction. The tendency in which it is of very interesting is given as positive sign. And say for example an electrode is going for oxidation, its oxidation potential is given as positive value, and in case if the electrode is tend to go for reduction, then its reduction potential is given with positive value. Whereas unlike that of this tendency, as a result of this tendency, the electrode is of having some sort of that is charge developed, and you remember that charge is the net result of the tendency, and because of the tendency when it is going for oxidation, it is accumulating the electrons on metal rod and thereby that will get negative charge. Whereas in case if it is reduction is from metal ion, and thereby it will abstract the electrons from metal rod and that metal rod will accumulate positive charge. So the charge is different. Charge may be negative or positive. It is nothing but an ultimate result of the tendency of the electrodes. Whereas the tendency is the potential. Clear with all this? Now we are coming to just we defined in the previous class. What we defined is nothing but electrode potential. That is nothing but the potential developed when a metal rod is deeper in its salt solution, or a non-metal, gaseous non-metal is made in contact with its anionic salt solution. That potential is electrode potential. And now in this session what we are going to measure is what is standard electrode potential, and if we know the standard electrode potentials of the single electrodes, how to measure the standard EMF of the cell, and then how to measure the standard EMF of the cell. If we know, first of all we have to go for how we can measure the standard electrode potential. We can define standard electrode potential, no doubt at all, but how to measure it, how we can measure, all these we are going to discuss in this session. Clear? And first let us define this standard electrode potential. Standard electrode potential, and you remember this can be represented in case of metals, it may be represented as E naught m to mn plus. It is oxidation, or we can represent E naught m n plus to m, it is reduction. Altogether standard is with naught. In case if it is electrode potential, just we can write E m m n plus, E m n plus to m. Just you observe here, metal oxidized, so oxidation potential, metal ion reduced, so reduction potential. Just, but it is at standard condition, that's why it is not. And in this case it is not standard condition. At any condition it is electrode potential, but still metal oxidized, metal ion reduced, so it is oxidation potential and it is reduction potential. Clear? And now the question is, what is standard electrode potential? What is electrode potential? Just we know when it is electrode, a single electrode, either it is metallic or non-metallic. Just you remember, if you recall your previous sessions discussion, non-metal is nothing but non-metal not useful to prepare the rod, but with the help of a neutral metal rods like gold or platinum, by maintaining a glass hood, we are pumping the gas into the solution where common ion is present. Clear? So like that, even in that case, when the metal rod or non-metal glass hood maintained, it is deep in its own salt solution, the potential developed is nothing but electrode potential. Here if you observe, we are not concerned about the concentration of the electrolyte. We are not referring the concentration of the electrolyte. So that's why then it is electrode potential. Just but when a metal rod is dipped in its own salt solution of 1 molar concentration, 1 molar, that is unity concentration, when the concentration is confined, then the potential developed around it is standard electrode potential. Standard electrode potential. It may be reduction potential, it may be oxidation potential. In case if it is oxidation potential, just it is considered as standard oxidation potential, SOP. If it is related to reduction, then it is represented as reduction, standard reduction potential, that is SRP. These are the two electrode potentials in their standard conditions. Clear? And now when we know SOP of any element, then simply by taking the negative sign of this SOP, it is nothing but negative sign of SRP. Similarly, SRP is nothing but an opposite sign, that is negative sign of SOP. Just that means when for an electrode, if we know standard oxidation potential, opposite sign when we are providing for that value, it will give reduction potential. If we know reduction potential, opposite sign to that one is nothing but oxidation potential. Just by making opposite sign, we can get opposite potential. Clear? And now one more very important here is nothing but in IUPAC conventions, already we discussed, in IUPAC conventions it is mandatory to consider all electrode potentials only in terms of SRP values. Clear? Only in SRP values we have to consider in general. Clear? And how to get the SRP? Because some metals tend to go for oxidation. So you go for oxidation. When you are getting the oxidation potential, then take the negative sign of that oxidation potential, then you will get SRP. Conversion is easy. Clear? You can do like that. And now, so simply standard electrode potential is nothing but when an electrode is dipped or immersed in its own salt solution of 1 molar concentration. Concentration is unity or 1 molar. Then the potential developed is known as standard electrode potential. Just you remember, it may be oxidation or reduction. Already in previous class we discussed. The only difference is there we are not confining the concentration, but here we are confining the concentration to 1 molar. That is the only difference. Clear? Altogether potential is, what is potential? Potential is the tendency. Just you remember here 3 points you have to remember. Potential is tendency. Tendency two types. One is tend to go for oxidation. Oxidation potential is positive. Tend to go for reduction. Reduction potential is positive. And again, when it is oxidation, tend to go for oxidation, metal atom tend to go for oxidation. Whereas when the metal electrode is tend to go for reduction, just you remember, metal ion will go for reduction, not metal atom. Oxidation by metal atom, reduction by metal ion. Already we discussed about in previous session. And now, after knowing the SRP or SOP value, that means for two electrodes, if we know the SOP value for one electrode and SRP value for another electrode, how to measure the standard EMF of the cell, which is represented as, it is standard EMF of cell. It is represented with E0 cell. Just you remember. And E0 cell, actually what is EMF of the cell? If we define, it is nothing but the difference in the electrode potentials of the two electrodes that are used in the construction of the cell. Again I am repeating, the difference in the electrode potentials of the two electrodes is nothing but EMF of the cell. When those two electrodes are in their standard condition, nothing but when they are having the electrolyte solution concentration 1 molar, then the difference in electrode potentials is known as standard electrode potential, that is standard EMF of the cell. Clear? And now how to measure the difference? Just you remember, the difference is when both are in oxidation potentials, or the difference is when both are in reduction potentials. But actually, if one electrode is at oxidation potential and the other one is nothing but in reduction potential, just you remember, the EMF of the cell is nothing but the sum of those two. Again I am repeating and I am writing here. E naught cell, actually, even though it is defined as the difference between the electrode potentials, the difference between the two electrode potentials, here the difference we have to consider when both are in the same SRP or SOP. But if one electrode is in SOP and the other electrode is in SRP, the difference is nothing but the EMF of the cell is nothing but oxidation half electrode SOP plus reduction half electrode SRP. That is nothing but the sum of oxidation potential of anode plus reduction potential of cathode. That is equal to E naught cell. And now we know, in case if both electrodes are with SOP values, that means both these two electrodes are considered no SRP, only SOP, then how to measure? Now you can consider this. E naught cell is equal to OHE SOP, it is given, SOP is given, and SRP, we know SRP, but SOP value to get, and when SRP is no SOP value, how we can get? Just opposite sign to this, is it not? So here whatever, when they are providing the electrode SOP values, automatically the second one will get, SRP is converted to SOP, it is nothing but minus. So RHE, reduction half electrode SOP. Now you observe the definition appears here, the difference in the electrode potentials. Clear? And now if both electrodes are with SRP values, now I think you can rearrange them simply. SRP, here E naught cell is equal to OHE is having SOP, and when they are giving SRP means it is with negative, OHE minus OHE SRP value, and it is already in SRP, that is RHE SRP. Simply on rearrangement what you are getting is E naught cell is equal to RHE SRP value minus OHE SRP value. Here you know RHE is reduction half electrode and OHE is oxidation half electrode. Here also altogether here we are getting three different formulae. One is when the one electrode is with SOP and the other one is with SRP, and when both are with SOP values and when both are with SRP values. Are you clear? Like that. But even though in IUPAC convention this is correct, this is as per IUPAC we have to use, but while doing the numericals, the convenient method for us is this one. This is convenient method. So that's why in all our calculations in coming sessions we are going to use this formula. That's why you simply remember that. Oxidation half electrode SOP, reduction half electrode SRP. The sum of these two is nothing but E naught cell. Clear? And now with this one let me write. Now altogether here our question is, okay, we are after knowing the SOP or SRP values, the sum of these two is nothing but E naught cell. But the question is how we can measure. How we can measure? Already we defined what is SOP, what is SRP? No doubt at all. By definition, they are nothing but the potential developed around the electrode when that metal rod is dipped in its own salt solution of unit concentration. That is nothing but 1 molar concentration. We defined it. And when we are measuring these two, that is SOP of oxidation of electrode and SRP of reduction of electrode, the sum is now EMF of the cell, E0 cell. But the question is, how we can measure that standard oxidation potential? Here, how to measure? Let me explain that. Here, measuring electrode potentials, that is standard electrode potentials. Because why I am considering standard electrode potential measurement is, in case if it is other than standard condition, then electrode potential measurement requires Nernst equation. This can be done, that can be done with the help of Nernst equation. But in case of standard electrode potential measurement, standard electrode potential measurement, it requires only to construct a cell with a reference electrode. With a reference electrode, there is no requirement of the Nernst equation. Just we should possess, that means we should have a reference electrode. First, let me give what is a reference electrode. Reference electrode is nothing but known potential electrode. Known potential electrode is known as reference electrode. Known potential electrode. Known potential electrode means already, say for example, here the best example for reference electrode is hydrogen electrode. In hydrogen electrode, what we are considering is the E0 of this hydrogen H2 to H plus or E0 of H plus to H2. That means it is here undergoing oxidation. Already you know hydrogen is a different non-metal, and here it is undergoing reduction. In both these two cases, oxidation potential or reduction potential are taken as 0. You remember here one more very important conceptual question may appear in your examination. That is, they are asking which of the following statement is true. 1. Hydrogen electrode potential is 0. Standard electrode potential of hydrogen is 0. It is wrong statement, you remember. Then what is the correct statement? Hydrogen electrode potential is taken as 0. Very close to 0 but not exactly 0. That's why by default we are considering or we are taking it as 0. Clear? And now, so when it is taken as 0, that means already we know the potential of hydrogen. That's why it is known as a reference electrode. Reference electrode is nothing but the electrode for which the electrode potential is known. Clear? And hydrogen is the best example, and this reference electrode, and hydrogen is known as the primary reference electrode. Hydrogen electrode is known as primary reference electrode. Reference electrode is nothing but the electrode for which the potential is known. Clear? And now, so here to measure the standard electrode potential, we require a reference electrode. Already now we are having some idea about this reference electrode. That is nothing but the best example of reference electrode is platinum, hydrogen and H plus. That is nothing but hydrogen electrode. Hydrogen electrode in its standard condition is known as SHE or NHE. SHE refers to standard hydrogen electrode. NHE is referred to normal hydrogen electrode. These are the abbreviations for these two words. And here the electrode potential of that hydrogen, standard electrode potential of hydrogen is taken as 0. And now, before entering into measuring the electrode potentials, we have to recollect, just we have to memorize this one, E0 cell. We should keep in mind this one. E naught cell is taken as OHE SOP plus RHE reduction half electrode SRP. These two sum is nothing but E naught cell. Clear? And now, how to measure the electrode potential of an electrode? Just you remember, to measure the electrode potential of a given electrode, we should construct, that means we should build an electrochemical cell or voltaic cell, electrochemical cell, or simply it is also known as voltaic cell, with a known potential electrode, that means nothing but with a reference electrode. So to measure the electrode potential of any electrode, we should construct a voltaic cell. Voltaic cell with what? With a reference electrode, because already we know E naught cell, it is nothing but the sum of oxidation potential of OHE and reduction potential of RHE. So now when we construct the cell, we can read this value, and when from voltmeter we are reading this value, these two sum we are getting. And now when we are using a reference electrode either as this or this, and if we know one value, the other one we can get. That is the theme here. Again I am repeating, from when we construct a voltaic cell, from one unknown potential electrode, reference electrode, and the unknown potential electrode, the other one for which we have to measure the electrode potential. When these two are used to construct the net cell EMF, we can measure from voltmeter reading. Clear? And now the net cell EMF is nothing but the sum of these two. So of these two, if one we know as reference electrode, the other one can be obtained. That is the simple technique what we are going to use. And for that purpose, let us construct a simple voltaic cell with well familiar electrodes, which are frequently we are studying in the construction of a Daniell cell, nothing but zinc and copper electrodes. Let us consider this is voltmeter and this is zinc and it is hydrogen. We are constructing like this. Clear? And now from voltmeter reading, I think already all of you know that when electrons are migrating from in one direction, automatically the current is migrating from the other direction. So from the voltmeter reading, by the flow of the current opposite direction, we observe that electrons are migrating from zinc to hydrogen. When electrons are migrating from zinc to hydrogen, means here zinc is undergoing oxidation because de-electronation takes place. So that's why here the reaction is Zn, by releasing electrons get into Zn plus 2. So that's why it is OHE. And when it is in 1 molar concentration, it is having the potential SOP. Clear? And next, here hydrogen. When hydrogen is getting the electrons, by getting these electrons get into H, that is 2H plus, by getting the electron converted, reduced to H2. So it is RHE. Simply we know when it is going for reduction, it is SRP. So here we can observe only the tendencies. It is going for oxidation and the electrolyte concentration is taken as 1 molar, and that's why whatever the potential we are getting is oxidation potential, and that oxidation potential, because of the concentration of the electrolyte is 1 molar, is standard oxidation potential. Similarly, here the hydrogen is tend to go for reduction. The tendency is giving positive sign for the potential, that is reduction potential is given. And here this hydrogen is also maintained 1 molar concentration, because our intention is to measure standard electrode potentials. Clear? Don't get confused regarding the words what we are using in measuring this. Clear? And now with these two, when we observe the voltmeter reading, that is nothing but E cell. First let us write the formula here. That E cell is nothing but the sum of E naught Zn to Zn plus 2, because it is undergoing oxidation, plus E naught H plus 2 H2. It is already, this is E naught OHE or HE, OHE or HE. And now this E naught cell is, it is SOP, because at anode oxidation takes place, we observe, plus SRP, it is nothing but reduction SRP, and this value is found to be 0.76 volts. So 0.76 is E naught Zn to Zn plus 2 plus, what is SRP? Hydrogen. Reference electrode is hydrogen electrode. For hydrogen, the standard reduction potential or oxidation potentials are taken as 0. That's why it is 0. And now we know that the zinc E naught Zn to Zn plus 2, that is nothing but SOP, is plus 0.76 volts from this meter, voltmeter reading. In that voltmeter reading, the E cell we are getting, and that E cell is nothing but the sum of these two phenomena. And here we observe that zinc, from how we know that zinc is undergoing oxidation, just from the migration, the direction of migration of the electrons. From voltmeter reading, we know that electrons migrate from zinc to hydrogen, and when they are migrating like this, automatically we know that zinc is undergoing oxidation and hydrogen is undergoing reduction. That's why we are considering that zinc oxidation potential, because of standard condition, nothing but 1 molar condition, and the other hydrogen SRP condition. This is how we are getting the SOP of zinc. And now once we are getting this SOP, I think you know how to write SRP. SRP of zinc, what is SRP value of zinc? E naught Zn plus 2 to Zn, it is SRP. Reduction is just by taking this opposite side, minus 0.76 volts, that is SRP. Clear? And now let us move for another electrode, that is nothing but copper. In case if we are considering, because copper is also well familiar to us, because it is used for Daniel cell along with zinc. That's why again let us construct this electrochemical cell, that is nothing but voltaic cell. Again same scenario, voltaic cell with copper and hydrogen. Here it is observed that hydrogen, by releasing electrons getting into H plus, it is hydrogen electrode, and here copper by getting electrons reduced into Cu. Simply you can write this one, this copper is this side and hydrogen this side also, no problem at all, but only for convenience sake I am writing like this. Clear? And now, and in this case, once again it is observed that now electrons are migrating from hydrogen to copper. Previously here zinc is present and here hydrogen. Now when hydrogen, you may think, now let me write for your understanding. As usual, let us give the position of hydrogen on right side while we are connecting or constructing the voltaic cell. Thereby you will have a clear idea about this. Here copper is taken, here hydrogen is taken, and now both are in 1 molar concentrations. And now from voltmeter reading, it is observed that even though hydrogen is present this side, copper is this, electrons are migrating from hydrogen to copper. So that's why not the positions left right side, just you observe, it is a tendency of copper to go for reduction. That's why now hydrogen is releasing electron, and thereby from voltameter reading, we can observe that from hydrogen to copper the electrons migrate. So when the electrons migrate like this, we can say that hydrogen is undergoing oxidation. So this is oxidation of electrode. And copper, it is undergoing reduction, Cu plus 2, that present in the electrolyte solution, by taking electron reduce it to Cu. That's why it is Rhe. So with this voltaic cell construction, we know that the tendency of copper is to go for reduction, and hence here what we are getting is reduction potential, that is SRP, and here what we are getting is SOP. And now as usual we know that E cell is nothing, E naught cell is nothing but E naught OHE, that is nothing but OHE SOP value plus RHE SRP value, is it not? And now the cell value is found to be 0.34 volts. And now what is that value? Here OHE is hydrogen. Already we know that hydrogen electrode potential, either our standard reduction potential or standard oxidation potential, it is equal to 0. So it is 0, and this is RHE SRP. That RHE is nothing but copper. So from this E naught Cu plus 2 Cu, that is reduction potential of copper at standard condition is 0.34 volts. So once SRP is known, now to get SOP, that is E naught Cu to Cu plus 2, the value is minus 0.34 volts. Like that, by constructing a voltaic cell with a reference electrode, we can measure the the standard electrode potential of the electrode. Clear? Here reference electrode is known potential electrode. Generally hydrogen is taken as primary reference electrode, and hydrogen electrode potential is taken as 0. And this is how we are measuring the standard electrode potentials. After getting the standard electrode potentials, already we know how to get E naught cell. Clear? In the next coming session, when we are of measuring the standard electrode potentials, after measuring the standard electrode potentials and after getting the standard EMF of the cell, how we can apply these values or this formulae to measure the EMF of the cells if they are directly providing the SOP or SRP values. And one more thing is, here we came to know that this voltaic meter reading, construction of voltaic cell, all this. But if two electrodes are given, their SRP or SOP values are given, how to imagine which is going to be behave as OHE, which is going to behave as RHE. All these details we will cover in the next session. Okay, clear?